Without a network, we would not be able to search the internet to get information. We would not be able to have a central repository for grades, for course materials. My name's Charlie McMahon. I'm the Vice President of Information Technology. We're doing what some people would call a forklift upgrade. We're replacing every piece of equipment in the network. But I like to describe this as more than replacing everything from the ground up. We're actually replacing everything from below ground up. We're replacing all of the fiber on the uptown and downtown campuses. And the fiber is the fundamental architectural building block of the network upgrade.
If you don't own your own fiber, then you have to go to a carrier to get the connection between buildings. And so we had something called Metro Ethernet that connects to here. And the benefit is that we control our own destiny if you have your own fiber.
The future, clearly, in consuming entertainment content is IP-based. So it's absolutely necessary to do these upgrades for students to consume content in the way that they would like to.
And we had people that are now interested in e-portfolio building using Acrobat Professional to combine thesis, dissertation, and also just other credentials that students want to pull together into a comprehensive PDF, audio, video, websites, documents, thesis, and then share those with the world.
When we're finished with the project, that high performance networking will enable research that probably wasn't feasible before.
What I keep talking about is gesture recognition, and we're not quite able to demo that yet, but that's the ability to, if you've seen the movie Iron Man, where he walks into his lab and he starts waving his hands around and screens start popping up and things start happening, that's gesture recognition. We probably wouldn't pop up screens and build suits in classrooms, but we might want to be able to do student responses and do other things, and I couldn't even begin to conceptualize what our faculty will figure out how to do with that.
With every building that we have on campus, uptown campus, we have 12 strands of fiber coming in. And then that's 12 strands will come out to 2 core. So if something happened to one core, the other core will pick it up. So availability is very important to us in the network. So we have that done. And we have a 10 gig connection between downtown and uptown campuses right now. And on last Saturday, we also turned on the 10 gig connection between Tidewater and our data center.
Say you're in Tidewater and you're connecting to here. There's, in one direction, you come with the 10 gigabit uplink, and in the other direction, you come with a 10 gigabit uplink. So it gives you path diversity, is what that's called, so that if there's a accident, somebody digs in the ground and cuts the fiber, it doesn't affect service in any way.
With redundant connections, we have a lot of ability to deal with faults. They call it fault tolerance. So you want to be able to have problems in areas of the network that only affect small areas. And before, our network couldn't support that. We would have whole sections of the network go down because of something going wrong. We can see things going on in the network now, whether they're a security issue or whether there's some sort of machine-specific bug or something like that. We can see all of that stuff reported back in near real time because the network can support feeding all of that information in.
Yeah, what I'm going to have, the reason for this and for this path was to serve the mechanical engineering, because I'm already serving flowers out of this hole, I'm serving bogs out of this hole, and this hole, this is the 96 that's going to come.
Okay, so it would be these strands for pyramid.
That's right.
For telecommunications.
That's
generally speaking, going into any
now.
building on campus is 100 megabits. So we're now 100 times that. If we had upgraded every building to a gigabit, that would have been If going from 100 to a gig would be a factor of 10, so we're now a factor of 100.
It's not only that we have faster connections now between a person's laptop or desktop or smartphone back to the wireless access point, but we also have bigger bandwidth from the access point back to the core of the network. So we've eliminated many of the bottlenecks that have caused frustration when trying to use the wireless network in the past.
Right. By re-architecting the physical part of the network, we're building a network that is going to be fast for today and built to take on the technology of future routers and switches and core equipment, because they'll be using the same physical infrastructure to move those bits across.